3 asks us to find a volume. So to find a volume of revolution, the formula is pi times the integral of the square of the function if we're rotating around the x-axis, which we are in this case. We're rotating between 0 and pi of the sine curve. So pi is here, so we're rotating this shape here around the x-axis between 0 and pi. So that means we need to find pi times between 0 and pi of sine squared x dx. Now we can't integrate sine squared x dx straight away. We need to turn this into something else. And in order to turn it into something else, there's an addition formula, a double angle formula that we need to remember, and it's the cos 2x formula that equates to sine squared x, which is 1 minus 2 sine squared x. So if we want sine squared x, then we need to rearrange this if we don't remember what it is straight away. So if we rearrange this, we'll get that 2 sine squared x is equal to 1 minus cos 2x, and therefore sine squared x is equal to a half of that, 1 minus cos 2x. So that's what we're going to replace sine squared x with. So what I can do with this half is put that outside here with the pi over 2. So the volume can be written as pi over 2 between 0 and pi as the integral of 1 minus cos 2x. Cos 2x. So all I've done is put that half outside of the integral. Because it's a constant, I can do that, and it just makes this a little less messy. I won't have loads of halves all over the place when I'm putting my limits in. So let's go ahead and now integrate what we've got here. Integrate 1, we get an x. Integrate a minus cos 2x, we're going to get a minus sine 2x, but we're going to need to divide that by 2. And that's between 0 and pi. So that's going to give us, keep that pi over 2 outside. Substituting in pi, we're going to get pi minus sine of 2 pi, and sine of 2 pi is 0. And substitute 0 in, we're going to get 0 minus sine of 0, which is also 0. So all we've got is pi squared over 2.